largest moon and the second largest moon in the solar system, after Jupiter. This is the only moon in the solar system that possesses a dense atmosphere with cloud layers, much like a true planet. Scientists note that the conditions on Saturn's moon Titan are very similar to those of early Earth. The main difference is that Earth, being closer to the Sun, has always had a warmer temperature. Assessment, in many respects, Saturn. Titan's hazy orange atmosphere had long shrouded its surface in mystery for scientists, until the Cassini spacecraft arrived in 2004. Saturn's atmosphere extends to an altitude of approximately 600 kilometers, which is significantly higher than that of Earth. Due to its extremely dense atmosphere, Titan was long identified as the largest moon in the solar system. It wasn't until 1980 that the Voyager spacecraft was able to get close enough to confirm that it was indeed smaller than Ganymede. Titan's atmosphere is primarily composed of nitrogen, 95%, and methane, 5%, featuring highly complex atmospheric activity. It also contains the presence of organic compounds composed of carbon and hydrogen, often including oxygen and other elements. They are similar to the components found in Earth's atmosphere and are essential for life. Titan's atmosphere, in particular, remains an unsolved mystery. Because sunlight breaks down methane, scientists believe there must be another source replenishing the lost gas. One potential source of methane emissions is volcanic activity, although this hypothesis has yet to be verified. Saturn's atmosphere can escape into space through a mechanism similar to Earth's magnetic field and escaping the planet. This process is believed to occur similarly to the Earth's magnetic field phenomenon. Jet Propulsion Laboratory, JPL. The Cassini-Huygens spacecraft explored Saturn. Information about weather, climate, and geology has opened up new methods that give us a deeper understanding of our planet. Titan's surface has vast regions covered by hydrocarbon sand dunes. The sand dunes on Saturn's moon Titan may have a similar shape to those in the Namib Desert on Earth. Since methane exists in liquid form on Titan, it can evaporate and form clouds. Occasionally, these methane clouds produce methane rain, along with cyanogen clouds, creating distinctive weather phenomena on the moon's surface. On Titan, sunlight is quite weak and the climate is primarily influenced by seasonal changes in light. It is believed that with the existing conditions, Titan could potentially become a habitable place for humans in the distant future. Based on some models, if the sun increases in temperature and becomes a red giant star within the next 5 billion years, the temperature on Titan could rise sufficiently for stable oceans to exist on its surface. If this occurs, conditions on Titan could become similar to those on Earth, thereby creating a favorable environment for the formation and development of certain life forms. As more exoplanets are discovered, studying Titan's cloud-filled atmosphere has become key to helping scientists decode the atmospheres of those distant planetary systems. Recently, NASA released a study based on the groundbreaking data collected by the Cassini spacecraft during its mission to explore Saturn's moon, Titan. The study, published in the Journal of Transitional of Galactic Research Planners, states that scientists have discovered a sea located entirely on the surface of a celestial body. This sea has characteristics similar to those of Earth's seas, although it is smaller in scale and has a depth of only about 100 meters. A clearer analysis shows that beneath the ocean lies not water, but liquid methane. According to Dr. Valerio Padriali from NASA, Kraken Mare is the largest body of liquid ever discovered on the moon Titan. The newly discovered sea holds valuable composition of seabed materials, referred to as a liquid methane sea, but this liquid gas mixture is also blended with ethane. This indicates that the planet's atmosphere is also saturated with these gases, with methane being the primary component. The unique aspect here is that these characteristics are identical to those of primitive Earth. Methane and ethane have been found in ancient sediments beneath the ocean floor. Numerous studies, including a 2017 collaborative effort by NASA's Jet Propulsion Laboratory, the University of Maryland, the University of St. Andrews, the University of Lick, and the Brumeyerberg Space Institute, have shown that Earth's ancient atmosphere was rich in methane. There is even evidence that early life in the form of microorganisms emerged within this very toxic environment, before Earth underwent a major oxidation event, paving the way for the evolution of life as we know it today. Therefore, Titan could not only be a moon harboring life as NASA hopes, but also a laboratory, a time machine helping us study what once occurred on early Earth. NASA scientists have just revealed plans to build a submarine to send to the moon for the purpose of exploring the Kraken Sea. Searching for life on Saturn's moon Titan. NASA is supporting a mission using a balancing craft to search for life on Saturn's largest moon, the ocean world Titan. NASA has announced the Dragonfly mission, which is scheduled to launch in 2027. Dragonfly is a spacecraft, and this mission is planned to deliver a mobile lander to Titan. The mission's objective is to study prebiotic chemistry in environments with the potential to harbor extraterrestrial life at various locations on this moon. Titan is one of the most promising candidates for life in the solar system, as it is the only known celestial body other than Earth to have oceans and lakes of liquid. Although primarily composed of methane rather than water, Titan's surface is covered with countless organic compounds undergoing chemical processes similar to those that occurred on early Earth. Recent evidence suggests that Titan contains unique molecules capable of forming cells and enabling life to exist under extremely cold temperatures of up to -179 degrees Celsius. Scientists plan to use multi-rotor drone helicopters to collect samples at hundreds of different locations on the surface of the moon Titan. This is the second time humanity has sent a probe to Titan. Previously, in 2004, NASA's Huygens probe was launched to this moon, but it was not equipped with the tools to search for life.